Hello, in this video I'm going to look at detecting and exploiting reflected cross-site scripting in DVWA. If you want to play along, all you will need is an installed version of DVWA and a browser. We're not going to use any external tools, it's going to be run all through the browser. So we're going to start, we're going to log in, username admin, password. We're not bothered about saving that. First thing we want to do, once we've logged in, we notice our security level is set to impossible. So if we try an exploitation on here, it shouldn't work. So we're going to go to DVWA security and we're going to start with impossible. We come off from impossible and we're going to start with low. So change that to low, double check it's stuck, there it is. And we're going to look at reflected cross-site scripting. The way I'm going to walk through this is one way of doing it. There are lots of different ways. This is similar to what I would do on a real test, maybe not quite the same, but the idea is to show you one way of doing it and then you to go away and experiment yourself. So there's a form asking what's your name. So I'm going to put my name in here, hit submit and see what happens. So we notice two things. Hello Robin, so my name comes back here. But also up here on the query string, we get name equals Robin. If we have a look what's happening in the HTML behind this, we can do view source on the page. And if we scroll down, let's make that a bit bigger. What we will see is we've got hello Robin. And the reason name has been put up on the query string is because this form, the method on it is get. Now most forms you'll come across, the method is post, which means any input fields will be submitted in the request body. Because this is get, the input fields go on the query string. If you want to know more about that, do a bit of Googling, there's lots of documentation on it. But basically get will put things on the query string, post will put them in the body. This, because it's designed to be easy to exploit, we're using get. So, as I say, it takes input, type name, and it writes it back out on there. Let's get rid of that. Next thing I'm going to do is see what happens with special characters. So, characters I like, single quote, double quote. Let's put some angle brackets in, a bold tag, and my name again. Submit that. So what you'll see, the quotes and the close angle bracket have come back, but this time Robin is in bold, and the bold tag that we put in, this B tag up here, has not been rendered. So what that means is the bold tag has been taken as HTML, and that's why my name is in bold. Again, if we look at the source for that, we will see the quotes, the angle brackets, the bold tag, and the name. Alternate way of looking at that, rather than doing a view source on it each time, you can use the inspector. So we inspect that, come down here, angle brackets, bold tag, and name. What you'll notice in this is the inspector has tried to be nice and it's added the extra close bold tag. We'll just go back up here, view source again, scroll down. There is no closed bold tag in the actual HTML that was sent by the from the server. Inspector has added that. So if you are working on this and you're looking in Inspector rather than in view source, you need to be aware that Inspector will try and tidy things up for you. I do tend to use Inspector more than view source. Well, I use an external proxy most of the time, but if I'm looking at it in the browser, I'll look at it in here and just know that that there are certain limitations. So we've done that. We've got bold tags. We know tags being rendered. So let's close that. Let's go for a really easy attack. Script that says we want to run some JavaScript. Show an alert box. Close the script, and just to finish it off, we'll put my name in as well. So something I should have said at the start, the idea of reflected cross-site scripting, or cross-site scripting in general, is to get my malicious JavaScript running in the victim's browser. Using these script tags, what I will do is I will say, this is the code I want to run. And in this case, it's an alert, pop up an alert box. Alerts are the default kind of go-to things for demonstrating cross-site scripting. So we're going to say script tags, show me an alert box, and then put my name. Hopefully, if we submit this, we get our alert box that shows the JavaScript's been ran, and there's my name. Again, if we view source, this is what's been read into the page. The script tag, the alert, and the name. So there we have it. We've exploited reflected cross-site scripting on the low level. Let's move ourselves up to medium and see what we can do on there. Change that to medium. Again, just check that it's stuck. And go back in to reflected cross-site scripting. So the same as before, we're going to try angle brackets and just see whether we can get any HTML injection. And yep, we've got my name back in bold. You can't see the bold tag, therefore it's been treated as HTML. Should we try our script tag again? See what happens this time. So this time the script didn't work. Let's have a look at the source. And we've got our alert and our close script, but we haven't got our starting script. So lots of things could have happened. What I would suspect happened here is the developers know a little bit about this kind of attack, and so have chosen to strip out script tags. Now, this is a common way I see to try and defend against cross-site scripting, and it's not a great one. Let's see if we can bypass it. Lots of different ways to try and bypass it. What we're going to do here, because a lot of programming languages are case sensitive when they're doing tests, or when they're doing comparisons, I should say, let's try some uppercase. And there we go. We've bypassed the restriction. The filtering restriction, whatever it is probably going to be they're testing for script in lowercase, and if they find it, they're stripping it out. HTML in general is case insensitive. So if all the developers are testing for is lowercase, or they forget to put the case insensitivity flag on the check, then this is a nice way to bypass those kind of protections. And if we view source, just confirm what we've done. There we go. There's our uppercase script tag. Last one. Let's move up to high. Back into reflected. And just to make sure, I'm going to go with the same thing as I've done before. Yeah, we've got our HTML injection. Let's try our basic script tag. That fails, and that's slightly different this time. We've just, all we can see is the close angle bracket. So let's have a see what we've got. Yeah, in the HTML source, all we get is the close angle bracket. So in this instance, they're doing some extra strips, some extra validation, some extra stripping, but we're not sure what. Let's try our case uppercase version, see if it's case sensitive again. Nope, this time they've obviously turned case sensitivity off, and they've worked. Let's try a script tag and see if we can put something else after there. So let's put a bit of garbage in and see what happens. Nope. So it looks like they're doing something with script tags. Now, script tags aren't the only way you can run code. Another nice way is to use event handlers. And if you don't know what event handlers are, the W3C Schools has got a really good page on them, good description. Basically, you can add an event handler to HTML tags and say, do this under certain conditions, so when an event happens. And you've got things like after something's printed, after you've gone online, if you resize the page. You can do it on form events, so on blur, on focus, keyboard events, key presses, on mouse clicks, all sorts of different things. Strongly recommend have a look through this if you're going to try this kind of attack. The one I'm interested in here, the one that works best for me a lot of the time, is on error. So scripts run when an error occurs, and I find that combines really well with image tags. So we're going to do an image tag. I'm going to say source X. So load an image called X from the server. Now that won't exist. So what we can do here is we can say on error show an alert box. If we submit that, we get our alert. And if you have a look, there's our broken image. We bring up the console and we have a look on the actual console bit. Let's refresh that. And what we should get is we get our alert box. We get our get for the image X and the 404. And because of that 404, the on error event handler is triggered, and that's ran the JavaScript showing the alert box. As I say, you can do lots of different things with this. You could put up a paragraph tag and do a mouse over. You can do on loads, on focus, on key clicks, lots of different ones. Something I've seen here occasionally with developers is they know of certain what they would consider bad events. So they've heard of on error, they've heard of on load, on key press. So they will try and strip out or in some way invalidate those particular events. But having a look at this page, there are lots of different events you can use. So if you find on errors being blocked or on click is being blocked, go through the rest. I've had really good success by just throwing every single one at it with an alert box to see what happens, and one of them triggers. So don't just stick with on errors, try the other ones. So up to now we've managed to get reflected XSS in the low, medium and high levels. Let's just have a quick look at some source and we'll see why we were able to do this. So we'll start with the low. In the low, you don't really need to understand too much PHP on this, but basically what it's saying is if you've submitted the name and it's on the query string, which it is, there's name on the query string, then write that directly into the page. And this is where this is the cause of most cross-site scripting that I see. User-provided content being written straight into the page. We move up to the medium level. As we suspected, they were stripping out script tags, but str replace is case sensitive. So this is looking for lowercase script and replacing it with empty. This is why when we changed it to uppercase, it worked. We could have also just, I don't know, made the I a capital letter. That would have bypassed it as well. And again, once it's stripped out, it's being written straight into the page. High level, this is getting a bit more complicated. They search for the word script using a regular expression. The /i on the end is case insensitive, but they're also allowing for other characters between the script letters. Not the best way of doing it, it's a bit complicated, a bit weird, and this is why we were then able to bypass this using an image tag, because image tag does not match script. So again, in the end, it's written straight out into the page. The reason this won't work on the impossible level, well, we're doing token check, don't need to worry about that. They're using HTML special characters. And what this is doing, this is encoding any HTML that's entered. So this would encode the bold tags, the script tags, the image tags into a form that will not be processed by the browser. It will just be dumped out as straight text. So the impossible level does it correctly and is not vulnerable. Okay, so what's the point in all this? We've managed to run a bit of code in the browser and we've popped up an alert box in our own browser. So what? Well, the main use for this obviously is to try and attack other users. And because in this instance the string goes on the query, the malicious code goes on the query string, this is fairly easy to do. So what we're going to do is we're going to open a new browser in incognito mode. We're going to go back to DVWA and we're going to log in as a different user. So this time we're going to log in as Gordon B. Username Gordon B, password ABC123, and log in. And for this to work, because we started impossible, we've got to change ourselves. We can drop to low, it doesn't really matter. So the scenario here is, as the attacker, I've gone into this browser on my own, I've worked out how this works, I've got a nice attack string that works and it shows an alert box. I copy that, I then in some way send that to Gordon. So either in an email or dump it in a forum, something like that, and say, hey look, I'm having trouble, I'm logged in, I've done this, I've done that, and when I get to here, it all fails. Could you have a quick look at this link for me and see what happens to you? And this is the link. So Gordon gets the link, clicks on it, and there we go, we've ran our malicious JavaScript in Gordon's browser. At this point, I can do pretty much anything that Gordon can do while he's logged in. So if he's an administrator and can add users, I can add a user. If he can change passwords, I can change passwords. I've got full control over it. I can read the data. So if he can read the user list or the credit card list or something like that, so can I. Another attack I quite like is taking the rendered page and rewriting it to look like a login form. So Gordon clicks on it, has a look at it, and for some reason he thinks he's been logged out. He puts his credentials back in again. Those credentials get sent off to my server. Page rewrites, he's back in as normal, and he just thinks it's some weird glitch on the site. He doesn't really notice anything bad. Sites log you out all the time. But I've now captured his credentials. So there are lots of different ways you can use this kind of attack. I'm not going to cover them in this video. I'm going to do a separate video on that and just go through a few nice attacks and nice ways to use cross-site scripting. So hopefully you enjoyed that, and I shall be back soon with some other vulnerabilities, some other walkthroughs, and I say hopefully some way of talking you through different ways to use cross-site scripting once you actually found it in a vulnerability. So see you next time.